Okay, so we're going to look at number 72 here. So here's the way it works, basically, is that we're going to assume that all of the carbon in the 33.5 milligrams of CO2 comes from the initial compound, and that all the hydrogen in the 41.1 milligrams also comes from the original 3.35 milligrams of CO2. Okay, so in other words, or not of CO2, of the original compound. So in other words, we're assuming that there's nothing else other than the compound, oxygen, and then our two products. Okay? So, I mean, essentially we've got an equation that kind of looks like this. Okay, so X plus O2, X is what we're looking for. That's going to yield for us H2O plus CO2. Okay? Sorry for the writing, I'm getting used to this. Okay, now, that being the case, so here's what we're going to do. We're going to take our grams of CO2, which is in milligrams, so we're going to convert that real quick. So that's 0.0035 or 335. Okay, that would be 33.5 milligrams, but that's going to be grams. CO2. Okay. Again, sorry for the writing. I'm getting a little used to it. So we're going to convert. We're going to take the molar mass of CO2 then. That's mole of CO2. 44.0 grams of CO2. Okay. Then we're going to take a mole ratio. So for every 1 mole of carbon, okay, there's 1 mole of CO2. Okay, there's only 1 carbon in the compound. So that's where we get that ratio from. We'll see that's going to be different for our hydrogen in a minute. Okay, and then the molar mass of carbon, okay, over 1 mole of carbon. Now, when we punch all that, sorry for the writing, we punch all that out into the calculator, what we get then is 0.0009, whoops, there's another 0 there, 0.00914 grams of carbon. Now, what does that mean? Well, we can immediately figure out the percent because we know how much the original was. The original, remember, was 35 milligrams. So if we take that amount, divide it by 35 milligrams of the original compound, okay, that's X, and then we multiply it by 100 to get a percent, that's going to give us 26.1%. Okay? So that's that part. Now, the hydrogen part works much in the same way. We take the amount of hydrogen that we had, which is 0.00411 grams of H2O. Okay, we're going to do the same basic principle here. Okay, so molar mass of H2O. Okay, then we do the mole ratio. Now, for every water molecule, we have 2 moles of hydrogen, right? It's H2O. Okay, so that gives us a 2 for our mole ratio here. That's one big difference from the first step. And then the molar mass of hydrogen. Okay, so once we do that, okay, that is going to equal 0.000460 grams of hydrogen. Now, again, we're going to take that and divide it by the total, that 35 milligrams. So divide it by 0.0035 grams. Okay. Multiply the whole thing by 100, and we then get 13.1% hydrogen. Now, if there are only 3 things given to us, then So if there are only three things given to us, then we can immediately figure out what the percent of oxygen is. Okay? If 13.1% is hydrogen, okay, and 26.1% is carbon, then that means I add those together, subtract them from 100, and so what do we get then for our last element, which is nitrogen in this particular case? Okay, our nitrogen then is going to be 60.8%. Okay, again, how did we get to that? Sorry, I'm trying to get all this stuff erased. Learning the program. Okay, so then if we take 26.1%, that's the carbon, plus 13.1%, okay, that's the hydrogen, plus the nitrogen is X, okay, it all equals 100, so that means that 60.8% is nitrogen, okay. Now, once we get that, it's a regular old empirical formula problem. I've got 60.8% nitrogen, I've got 26.1% carbon, got 13.1% hydrogen, and then we're going to do all of our normal empirical formula stuff where we assume that we have 100 grams, right? So we divide each by their molar mass. So that's going to be 14, it's going to be 12, and that's going to be 1. Remember, on the top of each is just 1 mole. Okay, and obviously on the bottom of each is grams of each element. So grams of hydrogen, carbon, and nitrogen. Okay, multiply those out. Okay, so we get 2.17 moles of carbon. We get 4.34 moles of nitrogen, and we get 13.0 moles of hydrogen. And then remember, what we do from there on out is we divide by the smallest. So we're going to divide everything by 2.17. Okay, and that's going to leave us with pretty close to whole numbers. So that's going to leave us with 2, 1, and 6. So our formula then becomes, we usually want to put the carbon first, so C1, N2, H6. And that's it.